Hello everyone. Today we are going to learn about CNN. First see what is CNN. Convolutional neural network is a deep learning model specially designed to process and understand images. It is widely used in image classification, object detection, segmentation and image colorization. Now let's see what is lab. Lab is a color space consisting of three channels. L is for lightness like brightness or grayscale. A is for green to red color axis. B is for blue to yellow color axis. Lab separate brightness from color. L contains only intensity information while A and B contains all color details. This makes lab ideal for image colorization tasks. The CNN takes the L channel as an input and predict the A by B color channel. Now let's see the importance of CNN. CNN automatically extract features from image without manual programming. They handle high dimensional image data efficiently. CNN learn complex patterns such as colors, shapes and textures. They achieve state-of-art accuracy in many vision tasks, perfect for tasks where human design rules are difficult.
So let's see how it works in the real life. These lines, it loads the image. Then I flip the dimension because RGB to lab expects height into width to channels. Then I convert it to lab, and finally I flip it back to channel first format for PyTorch. This line here I just pick the first channel, which is the L channel. Unsqueeze simply adds back the channel dimension, so it becomes a one channel grayscale image. And this takes the remaining two channels, the A and B, and that becomes my label.
So my CNN is basically an encoder and decoder. The encoder tries to understand the grayscale image like detecting edges, shapes, textures. The decoder then tries to reconstruct the missing color channels. This layer takes my grayscale image and extracts 32 basic features from it, things like edges and patterns, stride to shrinks the image so it becomes smaller but with more channels. Batch norm is just helping stabilize training. It keeps the activations in a good range. Transverse convolution expands the image back to a bigger size. So this is like starting to rebuild the image from the futures. This final layers gives me two channels, the predicted A and B colors. Now this pass the grayscale image through the first con, normalize it, apply ReLU, basic feature extractions. This go deeper, detect more complex patterns. This start reconstructing, unsample and clean it with batch norm and ReLU. This is final step, produce the two color channels. Training is straightforward. For each batch I take the grayscale L channel as input and the AB channel as the target. The model predicts what the AB values should be. Then I compute MSE loss between the predicted true AB channels and update the network weights. This gray is my L channel, the input color is my AB channels, the output I want the model to learn. This run the grayscale image through the CNN to get predicted AB channels. This updates the weights so the model improves on the next iteration.
See the output. Currently is training the model. This is our actual image. This is the converted image with to lab color space, and this one is the predicted image which the model predicted based on the training data set. So you can see it has managed to match the colors with the actual image. Currently I only used 10 epochs. If you increase the epochs to 50 or 100, it will the accuracy will be increased.
Now let us look at different application of CNNs. CNNs are used in many real world areas because they are very good at understanding and processing images. First we have image classification. This means identifying what an image contains. For example, detecting if a picture has a cat, a dog, or a handwritten digit. CNNs learn pattern from millions of images and classify them accurately. Next is face recognition. CNNs help in biometric systems like phone unlock, attendance systems, and security cameras. They learn unique pattern of human faces to verify identity. Then we have medical imaging. CNNs assist doctor by analyzing X-rays, MRIs, and CT scans to detect diseases early. They can highlight tumors, fractures, and other abnormalities. Self-driving cars are also use CNNs. They detect lane markings, road signs, obstacles, and pedestrians to help the car drive safely. Another important use is image colorization, which is exactly what we are doing in our project. Here CNNs add color to black and white images and make them look realistic. CNNs are also used in object detection. This involves finding multiple objects in a single image, like detecting cars, peoples, animals, and traffic signs. Some popular algorithms are YOLO and SST. Finally, video surveillance. CNNs help monitor public places by detecting suspicious activities, identifying people, and enhancing security. So, overall, CNNs plays a huge role in modern technology, for healthcare to automotive systems to entertainment.
Moving on to the conclusion, the model is able to identify the correct pattern or shades in which the color must be filled, or we can say that the model is able to separate out the portion which is needed to be colored to get colorized image, but is not able to predict the accurate color for that shade or portion all the time with respect to the original image. With the help of feature extraction with ResNet, the problem could be solved easily. The result also reflects the actual requirement for GAN and other image colorization techniques.
Thank you.